Hey everybody, back again. Mastery quiz number 13, geometry. A little practice for you, a little probability here, geometric probability. Here we're looking at a dartboard basically, You got a dartboard that's 10 units across, 10 inches, 10 feet, 10 yards, whatever, doesn't matter. And we're going to assume that that's going to be a 10 by 10 square, all right? And in this particular question, we're looking for what is, if a dart hits the board, what's the probability it will land in region J, which is the ring. We're looking at the big donut shape, the lightest shaded area there. So we got to find the area of that. What are the chances of the dart hitting just that donut area? Well, in geometric probability, your probability here is going to be a fraction, of course, and your desired area will be on top. And in this case, our desired area is just that big, wide ring, or donut, region J, over our total area. And our total area of this shape is going to be the area of the square. Okay? So how do we find that? Well, the area of the desired area, again, I'll shade it here a little bit, maybe we can see. That's the area I want. Well, what I'm going to have to do is take the area of the big circle and pull out the area of the inner circle. So the desired area is going to be the radius of the big circle is going to be it looks like a total of 4. So we're going to go pi times 4 squared. Now that's going to give me the area of the entire circle. I don't want that. I want that middle portion, that shaded area. This area I want all pulled out of here, and that has a radius of 2, so I'm going to subtract pi times 2 squared. Now that'll give me my desired area, the area of the ring, over the total area. Well, the total area is going to be the area of the square, which is going to be 10 times 10. Alright, let's crank this sucker out here a little bit here. Up top you got 16 pi. We're going to take away 4 pi. All over 10 times 10, which is 100. 16 pi minus 4 pi is going to give me a 12 pi. All over 100. And we like to leave pi in our answer if we can. So all we have to do is maybe reduce the 12 over 100. And that would give you 3 pi over 25. And this would be an acceptable answer at this point. If you'd like to crank that out and put it in a decimal format, you can certainly do that. 3 times pi. We're going to divide that by 25. In a decimal format, you'd get 0.3768. So that would be about, of course, 37.6 or 7% chance of hitting that region J. Typically, you like probability in decimal format. You're going to want to multiply that out by pi in the end here to get a decimal answer. Okay? Next question. Similar question, same shape, just a little different area, I think, here. It says if the dart hits the board, what is the probability it will land in region L, which is the circle? Region L is the tiny circle, the one in the middle. So again, our desired area, our probability, is going to be the desired area. The desired area is just that small inner circle. Well, that has a radius of 1. So the desired area is just going to be pi times 1 squared over the total area. Again, it's a 10 by 10 square, which give me 100. So I basically get pi over 100. Basically move the decimal here. Alright, your pi is going to be 3.14 over 100. You divide by 100, you just move the decimal a couple places, you end up with 0.0314, or about 3.14% if you write it as a percent. Alright, a little bit easier there, less work to do. The desired area was just a simple circle. We didn't have to, it wasn't a donut shape, so it was a little bit easier to handle. Next question. Same picture, different question. If a dart hits the board, what's the probability it'll land on the outside of region J? Now, outside means the area between the square and the largest circle. You're looking at the white or the lightest shaded, this area out here. We want to know what's the probability of a dart hitting on the outside of that circle. Same deal here. The probability is your desired area. So we have to figure out, how do we find out just that area that's left over on the outside of the circle? Well, the desired area here is going to be the area of the square, which is 10 times 10. But now we don't want the whole square. We want to take away the area of the largest circle. The largest circle has a radius 4. So I'm going to subtract pi times 4 squared. All over again, the total area, which is 10 times 10. Again, 10 times 10 is 100. So here we go. Let's clean it up. You got yourself 100 minus 16 pi all over 100. And at this point, you might as well grab your calculator, do a little calculating here. You're going to go 100 minus 16 pi, which is 3.14 if you want to put it in decimal format, depending on what kind of calculator you have. And we want to divide that. That ends up to be about 49.76. We're now going to divide that by 100, move the decimal again. You get 0.4976, or about 49.76%, almost a half. All right, so 3 different questions, very similar, just dealing with a different area each time. You got to kind of use your noggin a little bit and think about what that area is that you're looking for and what you might have to do. Next question. Basic probability question using marbles in a sack here. You randomly select a marble from a bag. The bag contains 15 gray, 22 purple, 32 orange, and 11 pink. What's the chances that you reach into that bag and pull out an orange marble? Well, again, with probability, your desired outcome is what you're trying to achieve. That goes on top over your total outcomes possible. All right, in this particular case, what do we want? We want an orange marble. Well, how many are there? There's 32. That's going to go on top. Now I have to figure out, okay, how many total outcomes are there? What are all the different possible marbles that I could pull out of there? Well, there's 15 gray, 22 purple, 32 orange, and 11 pink. I think I got to add all those up, and when I do, I believe I get 80. And the directions here say reduce your fraction in a ratio into lowest terms. So we're not going to put this one into a decimal. We're going to put this, leave this a fraction. Let's start reducing this thing. You know, simplest way, cut each one of those in half. We know that it'd be 16 and 40. You know, you can reduce it even again by cutting that in half, which is 8 over 20. And you can even cut that one more time. 4 over 10. Wow. How about one more time? 2 over 5. Now that's the old school, simple way, elementary way of doing it. You can always find a common factor of 32 and 80, of course, and pull that out. But your final answer would be 2/5, 2 over 5. Bam. All right. Make sure I did that right. If I did it, yeah, we're good. All right. There you go. Four questions. Probability, lots of fun in there, all right? In this particular question, just make sure you're reducing your fraction all the way until you're done, okay? All right. Good luck to you.